Okay, what we have here are some application problems involving trig functions. So we have this function h, which is cosine times blah 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 with some multiplication and addition happening to it. But at its heart, it is a cosine function. Okay, and we've hinted at this before, but what these functions look like, at least sine and cosine, are these kind of nice oscillating waves. Okay, so these are useful to us in real life to model anything that kind of has maybe an average value, but then kind of cycles above and below it over time. So in this case, we're talking about time and daylight for this particular example, right? So it says the hours of daylight in Chicago oscillate. Oscillate just means kind of goes back and forth like this, from a low of 8.5 hours in January to a high of 16 hours in July. So we already knew that, right? The days are longer in the summer, very, very short and depressing in the winter, right? So we could use a trig function to model that. And we want the number of hours of daylight 3.9 months after January. So that'd be about at the end of April. And, well, first of all, just make a note here. That means t is time, is 3.9. So what we want to do is we want to find h of 3.9. And this is important too. It says leave your answer as a decimal rounded to 3 places. Okay, so what that means is I don't need to find the exact value from the unit circle. I can just type this into my calculator and see what I get. So I'll show you what that looks like. So the first thing I'm going to do is I'm going to check that I'm on the right units. So we are going to be in radians here. When in doubt, use radians. It's very rare that we'll use a trig function to analyze something in real life like this and be in degrees. And then I'm just going to type it in exactly as I see it. Okay, so here's my function. So I use the cosine button, and I use the pi button. So pi is second, and then the little caret. It's important that you use pi, the button, because it uses the full value. So if you use 3.14 or something like that, and you round, you're not going to be as precise. So I did pi over 6, and then times 3.9, which is my t, and then close parentheses, plus that 12. And that's my result. So 13.702. 4 tells me to round down, right? And we're going to round it to 3 decimal places because that's what it asks for. And the reason I ask you for 3 decimal places regularly now is that is the rule on the AP Calc exam. So we'll do 3 decimal places usually through the rest of our time together. So 13.702 is my answer here, and that's it. Oh, and I said and, I cut it off here, but and label, so we'll say 13.702, and then H stands for hours. We could be more specific and say hours of daylight. So that's an example of an application problem. We're doing what you already knew how to do, is essentially we're plugging in values into functions. You've known how to do that forever, but we're using these trig functions. In our next example now, this one's about the water level on Lake Michigan. So you guys may or may not know that water levels on big bodies of water like that tend to vary throughout the course of the day. It's called the tide, right? It's because the moon is pulling on the water. On Lake Michigan, it's very small because there's not that much water in Lake Michigan, but in the oceans, it's pretty significant. So because this is a cyclical relationship, we can model it using a sine or a cosine function. And we have 5 sine pi over 6t. And it says t is hours since midnight. And f is the difference between the water level and its average. The difference between the water level and its average. So what that means, right, is there's some average water level, and then we fluctuate above and below it over time. And, okay, we intend to go to the beach at 11 a.m., and we want to find that difference in the water level. So that means t is 11. And this one, it says leave my answer as a fraction and rationalize if necessary. So here we're going to be in exact terms is what this means. In other words, we're going to use a value off the unit circle and not give a big decimal that we have to round. Okay, so I'll say f of 11. This becomes now a lot like that last Delta Math lesson. 5 sine, and then 11, I'll just write it in front. So 11 is my t, right? But it's 11 pi over 6 is what I get when I multiply pi over 6 times t. And then I'm going to go to my unit circle. So hopefully you have that handy in your notes somewhere. And I want sine of 11 pi over 6. So I'm going to find 11 pi over 6. It's all the way around here. And remember, sine is your y value. So that is equal to negative 1/2. Okay, so what I'm going to do is I'm going to replace that with this whole sine expression is equal to 1/2. And that's that, right? So 5 times negative 1/2, well, that's negative 5 over 2. And we don't need to rationalize because we didn't have any square roots. And then, what are we talking about? Negative 5 over 2 feet, I guess we'll say. I didn't give you units, we'll say it's feet. Okay, so notice we did this one a little bit differently than the last one. So this one we found an exact value off the unit circle, and that's because they did not say to leave your answer as a decimal like we did in the previous one up here. So nothing like that. We'll say instead the exact value off the unit circle because it's more precise. Next one. So suppose the average height of the water level is 10 feet at the beach at your favorite spot. What would we expect the water level to be at 11 a.m.? Well, remember this result that we got in our last question is the difference between the average and the current level, right? So if it's 10 feet normally, and we know it's 5 over 2 feet lower, let me just do this. Minus 5 over 2. And then 5 over 2 is 2.5, so you could say 7.5 feet here. Or you could say, what does that get you? 15 over 2 if you use fractions. Either is fine. So that's it. So we're just taking our answer from the previous one and we're using it a little bit. What this means, right, is if this line is 10 feet, the water level varies around that average, and we are at 11 a.m., a little bit lower than that, right? Okay, so at that particular time at your favorite spot, you have a little bit more beach to enjoy. I'd say we finished the hard ones. Here we're just converting radians to degrees. This one is actually even pretty easy because you can use the little trick of just saying pi radians equals 180 degrees. And then we get negative 180 over 9 is negative 20. Or you could set up a proportion as well. You guys crush the delta math of these, so either method that you choose is fine. And then my last one looks maybe weird and scary, but is actually just another unit circle problem. So we will evaluate these exactly. So exact value again means no decimals here. We're going to use what we get off the unit circle. And we want cosine 3 pi over 4, so that is here, right? And then cosine is my x value, so we'll say negative root 2 over 2 for that one. Plus sine of 7 pi over 4, well, that is down here. And again, that is negative root 2 over 2 again. And now we have to combine these, and maybe that's a little bit new to you. We're going to add them like fractions, and we're going to keep root 2 in our calculation. So what I'm going to say is, well, I have 1 root 2 here and 1 root 2 here. When I add fractions, I have like denominators already. The denominator stays the same. And then on top, I have negative 1 root 2 plus negative 1 root 2. Well, that becomes negative 2 root 2. So we kind of treat it like an x, right? So if it was negative 1x plus negative 1x, we'd have negative 2x. Same thing here. Okay. And then if we're real smart, we can even simplify that. So boom, boom, you guys probably saw that, right? And then we're just left with negative root 2. Okay, so this is actually the most convenient way to leave your answer here, especially if I had to go on and do more calculations with it. So if I had to do something else with this number to solve a problem, it'd be nice to have it in a nice simplified square root rather than like 1.12 blah 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 blah, right? Okay, that's it. That's the lesson. You'll see similar problems on your quiz, so hopefully you captured these examples to reference.